Hey guys, this is the recording of the free class we did a few days ago about web development interaction with Python and Flask. This is subject of our advanced Python programming course. So if you guys are looking to learn more about Python and web development in general, check us out. We do remote programming courses with real teachers and coding. They're pretty good. Check us out again. If you have any questions, you can always reach us out at questions@rmotr.com. We're always here to help. I'm going to start recording this session because I will send the recording later. If you guys miss something, you can just check it out. And I will also share my screen so we can get started. So first of all, motivation. Why are we doing this? We find that there are so many people that we have this course, right? Advanced Python Programming. We basically take from some basic knowledge and we explain and we go through advanced features. And the last week of this course is about web development. And what we have found out is that students are always surprised at how easy it is to get started with web programming. You know, they are looking at it as if it's this big monster, you know, that they are never able to get started. And when we start doing these, right, working collaboratively, they are amazed by how simple it is to build a simple website or actual, like a real API, you know, something you can build a mobile application and plug to it. So the idea of this class was exactly that, to show you how simple it is to get started with web development and how simple it is to get started with Flask. And once you guys have like that foundation, it's also simple to move to Django, right? Because it's basically the concepts are the same. So we are going to be using these slides today. I'm going to share them with you in a second. Give me 1 second. I will share them through the chat. Usually I will not pay attention to this chat window because as I'm sharing the screen, I can't see it. So if you have a question, again, just unmute your microphone and speak up. Something else that we will be working on is with this workspace that I can also share. This is a collaborative IDE. It's Cloud9. It was acquired by Amazon a few months ago, so maybe you guys heard those news. It's something that we always use to conduct our classes. If you guys start requesting access here, I will not grant it right now because I don't want to get distracted. I will do it later so you guys can start working, but basically you will be able to copy the code that I have here, and later when I grant access, you can start also modifying it. All right, so this is basically all the setup that we need. We're going to start with a few basic things with foundations, right, that we need to build the concepts to start working with web development. We're going to talk about a basic client-server architecture, and we're going to talk about HTTP. What we have found out in these years is that it's extremely annoying to have developers that don't know the basics and the foundations, the concepts behind the web. Right? They are building something, web applications, because they followed a few tutorials, but they don't know the concepts underneath. As soon as you have any issue, right, a bug, security threat, something, it's like everything falls apart. It's really, really important to understand the basics, to understand the concepts in order to build better application, more performant, more secure. Right? That's basically what we try to do. And it's not just for web development. We always try to focus on concepts, right? Things that, again, you can follow 1,000 tutorials, Udemy courses. We'd like to focus on concepts because that's what developers need, right? If I teach you how to use Flask, that's it. You will never be able to transition to something else. If I explain to you and help you go through the concepts of web development and how particularly Flask works, then you will be able to transfer that knowledge into different frameworks, different languages, different platforms in general, right? So that's basically the idea. To get started, this is one thing that we don't know about, well, but we do know about this class, is that the level from all of you will vary, right? There will be people that are just starting, there will be people more advanced, so we kind of have to set a common ground so everyone knows what we're talking about. The first thing we want to talk about is the client-server architecture. This is super stupid, this is super simple, but you guys will see how it interacts well with HTTP and maybe of a soft characteristic of HTTP. I'm going to tell you in 1 second. Basically, the web is built upon the client-server architecture, right? Clients interacting with servers. Client requesting something, the server serving that something, right? That resource, that thing that the client was requesting. In every client and server architecture, there are several actors that they will change how they work depending on what particular like micro architecture you're looking at, and we're going to see more about that later. The workflow is super simple, right? It's just the client will initiate the workflow, right? The life cycle of this workload, and the client will initiate these with, in this case, an HTTP request, right? We are talking about web development, so it's going to start the work with an HTTP request. The server will do some internal processing, and it will usually, this is a good example, right? 95% of the web servers out there will at some point communicate with a database. That might not be the case, but again, it's just a good common ground, right? It will communicate with the database will return something, and the server will return something back to the client. The first thing we can see here is that depending on what part of this schema we are zooming in, we can see that in this case, for example, the client and the server are well specified because the client is the browser in this case, and the server is the web server, right? The web application server. But if we move to some other part of this particular schema, we have that when the web server is or the web application, when it's communicating with the database server, the web app, which previously was a server, now becomes the client. All right, and also what we see is that we might have different types of client, right? 10 years ago, if you were building a web application, the only client you were supporting was a web browser, a regular web browser. Today, you are supporting many clients in every web application because we can have a traditional web application just serving HTML, or we can have a web application that it's actually an API supporting a mobile application or a smart TV or a fridge or other servers, right? So what we're going to see is that this simple schema where we have just 3 actors, now it will explode and we might have many actors, right? This server right here might communicate with a Redis server to store sessions, and it might communicate to a Dynamo server in the AWS cloud to store, I don't know, posts for a feed, and to S3, the AWS service, to store images, right? And you might have different clients, and clients, there is this new trend here. If you guys start checking out databases, like for example, WeThink database or Firebase, database from in this case is a service from Google, you guys will see that even clients are communicating directly from databases. So what we see is that this simple schema we have 10 years ago, now it's a much more complicated schema, right? What happened then? If I go back again, and here maybe older people like me can remember about these golden years, when you guys were communicating with many actors, there were different ways to communicate with those actors, right? So for example, the web browser with the server was communicating over HTTP, that was standard. But maybe your server was communicating with the database with a proprietary protocol, right? Just like the Postgres protocol that it has underneath. It's opening a TCP connection underneath and it's just communicating with it. Maybe if you had to access any external service, right, you may be using something like SOAP. It was a really common thing. And then you had other RPC technologies, remote procedure call technologies. So we had less actors, right? It was extremely uncommon to have more than 3 or 4 actors per architecture, but all of them had different ways to communicate between each other, right? Each one of those actors introduced a new way to communicate between them. As more actors were added, right, more services, more servers, more clients were added, I think that by accident, I don't know, maybe it was a good decision made by someone, the entire community, if you want, I don't know how to, this was more of a social phenomenon than something strictly technical. Everything switched over HTTP. It's like databases started to be supported over HTTP. I'm thinking something like, for example, Elasticsearch, or I think CouchDB has an HTTP protocol, a way to communicate with the database. Things that were extremely uncommon to have HTTP requests, to support HTTP protocols started supporting HTTP, and after a few years, pretty much everything worked on top of HTTP. And the concept of REST or RESTful APIs was introduced. So for example, today, if you guys want to, for example, build a service that works with Facebook, Twitter, Reddit, Yelp, all these services will have an HTTP, a REST API, right? The protocol will be HTTP. If you guys want to, again, work with, I don't know, Elasticsearch, S3 from Amazon, Firebase, everything will work on top of REST, which is the protocol underneath is HTTP. It's like we added more actors, but we unified the way we were communicating with different actors. So everything just like concluded in HTTP, and that was a good thing because HTTP is a pretty cool protocol. We're going to talk about it in a second. It will make things much easier for us developers, all right? So let's talk a little bit about HTTP. HTTP is a few characteristics. It's a stateless protocol. Every new request is going to be for the HTTP server and client. It's like if it's the first request ever. It's like first request ever. It's never holding state. And it's a text protocol. Everything sent you will be able to parse it and read it, right? Except, of course, if you are, for example, I don't know, submitting an image, there will be a part that you will be able to read, but of course, all the other part will be just binary garbage. But it's a text protocol. That's something good, right? If you guys, again, ever worked with something like remote procedure calls or proprietary protocols were binary, it was really hard to debug. Today, we can just read what it's being sent between clients and server, and we can make a good meaning out of that, and that's something really good. So, as we said, this workflow is started by the client. The client is making an HTTP request to the server, and that's how this life cycle starts. HTTP is a simple protocol, and it will have two main things, an HTTP request and an HTTP response, right? The two main communication ways here if you want, right? The HTTP request and the response. An HTTP request has this structure, okay? It will have a method, right? In this case, I have get. It will have a path or a resource, and it's also going to specify the protocol that that this client is using. HTTP started, I think, 1990 maybe. It was Roy Fielding's dissertation, PhD dissertation. So for a long time we had HTTP 09, then 010, sorry, and now we have pretty much all the web works on top of HTTP 1.1. There are a few experiments. For example, we have Speedy and we have HTTP 2, but they are not strictly, they are not really common. So we will probably always use HTTP 1.1. So we have a method, a resource, and a protocol. And this is really, really important. Maybe the first thing we have to say here is to talk about the method that we're using. HTTP will be used to fetch or to create or to access different resources stored in a server, right? So if we go back to this slide, we are trying to access a resource on this server. The type, when I say access, I can do different things. I can read it, I can create something. These things that I will be able to do on this resource in this server are kind of limited by this method, by the HTTP method. I cannot put anything, whatever I want here. There will be a few set of known methods that I can use to request this particular resource. The most common methods are get, post, put, and delete, and they correspond semantically to something like reading, creating, updating, and deleting, right? So think about it, the stupidest application that you guys can build. It will be able to read something, to create something, to update something, and to delete something, right? That's basically how everything works in programming in general. So the first thing we do is we tell the server what type of action we want to do. We want to get, we want to read, or we want to post, we want to create, right? Then we specify the resource that we are trying to act upon, right? So we want to get read / index.html. Or we want to post, right? It's creating, post to, I don't know, / books, and we want to create a new book in the library system, right? So that's the way we have to interact with the web server in a structured way, right? The web server will always act to a few methods. It's not like the options are infinite. I can just have a few set of known methods. The most basic thing that I can do with the server is specifying what do I want to do, get, post, put, delete, on what thing, what resource. Get, index, post to book, delete from author, right? But that's not enough for a proper communication. We usually have to include more information. And that's why we have these headers right here. So the base of this request will be, again, the method and the resource. What do we want to do on what resource? And then we have a set of headers to complement the information sent by the client to the server. In this case, I have just included a few examples. And what I want to note here is that these examples are important because, for example, when you guys work with HTTP, you're basically working on top of a network layer that works over the IP protocol, right? So these requests, when I try to make these requests to this server, I am making these requests to the server with IP address, I don't know, 101 something, right? One random IP address. One server located at one IP address can host multiple websites, right? That's pretty common, having virtual hosts and Apache, for example. So one server can host multiple, one physical server, not even a physical server, virtual machine, but let's say one physical server located at one particular IP address can host multiple web servers, right? So that's why we need to specify a particular host. It's like, I want to get /index from HTML from the host google.com. Also, there are some other things that I can provide to these particular information that I can attach to this request. One of them is, for example, accept. In this case, the client, without the server even asking for it, it's telling the server what type, what content type, what type of data it can use, right? What type of data it can read and it can understand. It's saying like, look, I want to read what you have located on index.html, and please send HTML back because this is the only thing that I can read, right? That I can parse, that I can make sense. The final header that I have here, it's useration, and here I usually say that this shows the goodwill from the client. It's like submitting more information, even though this information will probably never be actually used by the server, right? It's like it's submitting a request and it's just saying, look, my useration, right? The client, the type of client is just including this particular token right here, specifying what type of client it is. You guys can go, we can use this resource HTTP Beam to test a few HTTP requests, and I can, for example, just use the web developer tool right here, and I can see what it's going on with the HTTP request right here. So for example, I am just browsing with the network tab here, and I can see get, right? And I can see the response. 1 second, let me crop. There you go. I see the response here. We're going to talk about the response in a minute, but I also see the request here. If I click on view source, I can see the actual request made by the client. In this case, I see again the method, the path, right, the resource location, and the protocol, and I also see a list of headers that the browser is sending to this particular server. In this case, for example, I have the host, as I used to have before, I have the useration, and I have a maybe pretty long accept header. Here you can see the actual syntax that it's used for most of these headers. In this case, the client is saying that it accepts text HTML, XHTML, XML, blah, 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 and finally it's saying that it's pretty much accepting anything. It's like, dude, I prefer if you send me HTML, but you can just send me whatever, and I will try to make sense out of that whatever that you submit. All right, so you guys can start checking out the requests with these developer tools. So one quick note, again, the methods we have, the most common one are get, post, put, and delete. There are a few other: head options, patch, trace, connect. Trace and connect are not really used. Head options and patch are common if you guys are building APIs. Usually they are meaningful for machines, right? It's like for browsers and for people interacting. If you're just a regular user behind a web browser, the browser will just probably send get and post. If you guys are working with an API, you will submit a few more of these methods. If you guys ever had issues with, for example, jQuery making Ajax requests with cores failing because of the option methods, I think you guys already know what's the hassle with all these other HTTP methods. So if the the request has been sent. We have checked the request. If you guys have any questions, just stop me, but I assume that the request is understood. Then this server will do some internal processing, and that's basically what we're going to do today, right? After we understand HTTP, we're going to start building the web application that will do the internal processing. And after that's done, it will return an HTTP response. An HTTP response is also has super simple structure. Basically, it has the protocol version right here, and it also has later, after that, it has a status, right? Status is comprised by a status code, right, with a number, and also a human readable like status lesson, right, saying like 200, it's actually okay. So this is what usually machines use, and this is usually what human being read, right? Like that is what we understand. It also has a few set of headers, right, for the server to also extend the information or complement the information being sent to the client. For example, it's telling what type of resource, how these resources encoded. In this case, is text HTML, content length, right? How long it is, content encoding, right? Because for performance issues, the server has zipped, right, the response, and it's sending it with this like zipped, compressed. So the client should uncompress it first. You guys can also see the response right here, protocol version, status, and then you have a few set of headers right here, right? This is basically the structure also of the response. Something important to take into account, these status codes, as these HTTP methods from the request, the status codes from the response are also restricted or limited to a number of well-known status, right? You cannot put any number that you want right here, and they have a meaning, right? It's not the same thing to say something like 200 or 404, right? You know, 404, it's not found, 200, it's okay. Basically, the status codes will be divided by the range they are located, right? So for example, all the 100 status code will be information. Usually these are not really used, to be honest. All the 200, right, all the numbers in the 200 range will be successful requests, right? 200, the most common one, it's just okay. It's like the server is saying just whatever you ask, okay. There will be maybe more, how to say it, more actionable success status codes. For example, 201 means created. So if you tried to submit, if you made a post request to create a resource, right, post/book, you want to create a book, if you get a 201 back, the server is telling you that resource that you were trying to create is actually created, 201 created, right? 204 no content. There are different type of success status codes. All the codes on the 300 range are redirects, right? They will have different meanings. Like there is one that it says permanent redirect. The resource that you were trying to access here, it's no longer here. We have moved it to this other place. From now on, please go to that other place to fetch it. There are also temporary redirects, like this resource is not available right here. Please go to this other place temporarily, and you should expect it to be back to where you were requesting it in the future. 400 are errors from the user. This is a user's fault. It's like we did something wrong. When we send the request, we were, for example, 404, not found. It's like we try to access a resource that it's no longer there. It's my fault because I am trying to access that resource. It's the user's fault. 401, unauthorized. It's like I don't have the right permissions or I haven't provided the right credentials. This error, it's the user's fault, right? Usually you also have a 400 because you're, for example, forgetting data. You try to post to create a book, right? Post to /book, and you're submitting the title, the ISBN code, and maybe you're forgetting the author. So the response back is 400 bot requests if you're forgetting something. And then 500 are errors that happen in their server side. The user doesn't have anything to do with it. It's just under the fault is on the server side. Something went wrong on the server. All right. So this is basically really quickly how HTTP works. Again, if you guys want to focus on web development, please go and understand and read and try to study how HTTP works, right? It's the foundation of the web. Even though you guys end up working at 10 levels of abstraction above HTTP because you're using the latest Node.js web server, underneath what it's flowing, it's just HTTP. So it's important to understand. Go to read the RFC, the request for comment from the HTTP protocol, and again, it's going to be useful. All right. Any questions? Something? Good. So now we're going to say, we said that we investigated what happened when the request is being submitted and when the response is being submitted, and we know how to understand what is going on underneath, right? Like in between these two phases, the request and the response, and it's basically the work that we have to do with our Flask web server. So for this, we have built a testing project, I don't know how to call it, that will basically drive you in a set of known steps, right? It will drive you, and you will be able to understand how these things work in this step-by-step guide. We're going to be modifying it, changing it, but basically you guys can clone this repo and follow it, and hopefully it will also make sense later. All right. So basically what we're going to do is I'm going to open this here. Just 1 second. So you guys can see it's a simple GitHub repository. Well, I should add a README file. This basically what we have is the same thing that you guys can see right here. It's going to be a simple library system. To be honest, we at rmotr, we hate library systems. We usually try to work on really actionable projects, right? Something that is meaningful. Like we for example, we build a MongoDB based API using like a Twitter clone API, right? But that's something actionable. Then we can plug mobile applications, you know, something that really works. But for today, I think it's simple to maybe not have a cool project, but make it something that we can understand and see in these 2 hours we have. So how does it work? Basically, we have this run app file that is the first one, or it's the one that will kick off the entire development of this project. This run app module will import a set of apps that you guys can see right here, right? We can like skip over all of these and go back here, and it will set a few attributes when we run this script, and it will kick off the app.run method. This will spin a web server by Flask to let us work with our application. So again, of course, the actual deal of this class is located inside here, but let's just run this. Well, I opened something I shouldn't have opened. Let's run this. And see it in action right here. So this is basically working. I'm going to show you how in a second. So something important here. Flask is spinning a web server for us. All right. We start to see why we use Flask. Usually when we, in the advanced Python course that we do in this one, we use Flask in our 4th week to start with web development. And we usually have the question of why. And it's basically because Flask lets you understand way better what is going on with your web application. We love Django. All our internal systems are built with Django. We have a Django development course, but to be honest, it is so good that it ends up abstracting too many things for newcomers, right? It's like if you're starting with web development, it's usually not that good to be abstracted in the level that Django is going to abstract you, right? It's because you will build a web application, but you will not understand what is going on underneath. And again, we want to transfer concepts, right? We want to start slow, build with Flask, and then it's easy to transition to something like Django with the addition of understanding the concepts. Flask, if you guys start checking, it will not do many things. But one thing that it's going to ease our development is that it's spinning this web server for us. If you guys ever want to move this application to a production-ready environment, you will not use this built-in web server, but you will use something like, for example, Apache or Nginx or a more robust production-ready web server, right? But for development, this is pretty cool. This is a good feature from Flask. So we have spin the web server. We see that it's working. We have to understand what this up thing is doing. All right, so I'm going to go and start checking it out. I'm going to go to the first module first. And we can basically see here from a Python perspective, forget about Flask, that we are from this module importing this up thing. What is this up thing? This is an object that was created in this line. Basically, I'm just instantiating a class from this Flask class that I have imported here, and I am basically defining an object which is used later by the run app script or module, right? It's just importing this object, making a few modifications, and finally invoking a method, right? So again, concepts. If you guys ever have to debug a Flask application, it's super simple. It's just an object, a few methods. You can IPDB into it. You can pretty much do whatever, trace what is going on. It's basically an object, all right? Then, if you guys check what we have right here, when I try to access, sorry, 1 second, let me stop to say this. When I run this application here with this in this special IP address and in this special port, Cloud9 is opening up the port 80 in this location. All right, so this is something from Cloud9. It's not something that I have done manually, right? So if you guys will see that this is the workspace name, this workspace name, and then I have a dash, and then the username, which is basically this one. So that's why you guys can see this server working right here. So the resource that I'm trying to access here is basically slash. Here I have slash, nothing else. It's the root resource, right? That's what you guys can see right here. And basically this response that I'm getting, this text that I'm seeing here, it's basically what was returned by the function that I have right here. So we can start like guessing what is going on underneath. Basically, when you build a Flask application, you instantiate an application, just a regular object, and then you build functions, right, that will act for each one of the routes that you want to support. If you want to support something like slash about us, slash contact, slash location, something, you will create different functions to implement those views, right? About us is a view, contact us is a view, and then you will plug as the route to that particular function, right? So this is two parts. The way this plugging works It's basically we're decorating this function, right, with this special decorator from our app object. I don't know if you guys know how decorators work. For this class we try not to go into much detail into it. Just know that these are decorator. Usually in our course we try to understand what is going on underneath, because in week 3 we talk about decorators, and these are pretty advanced and good examples of decorators. Good examples both technically how they are built and from a design perspective, because they make these development so easy, right? It's like I have just defined a function, I decorate it with the route that I want to provide, and that's basically it. So for example, if this was something like about instead of slash, and I want to do something like about us, I will, if I try to access slash, now it should tell me not found, right? Do you see here 404 no found? Because I don't have a route for slash, but I do have a route for about. So when I go to about, I do see the successful response. All right. So that's the first thing that we have to understand about Flask. It's I will build functions and I will plug a certain route to that function. This function will fulfill requests made to this particular route or this particular resource right here. This resource, right, is what I specify here, and that's the processing being made here. Something cool that I don't know if you guys have checked. Flask is doing a lot of HTTP processing for us. For example, if I investigate or if I inspect these requests and responses, I will see that I'm just returning a string. This is a regular Python string. There is no magic here, just a plain old string. And if I check the network and I inspect what's going on in the HTTP response and request, I will see that, for example, my response, Flask is including by default the content type text HTML. Nice. I didn't ask Flask to do that, but it's saving me the hassle of including like required headers. For example, Flask is computing the length of this response, and it's also telling it, like informing it back to the client, right? It's doing Flask, is doing this work for me, and that's something nice. Good guy, Flask. So what we saw, I define a route, I provide a function to fulfill that route, and I just return a regular Python string, and that's basically the HTML being returned right here. You guys, all this knowledge, you guys are able to drop from this call and go build Google. Seriously, this is all that you guys need to know. As long as you can provide a good string right here, this is a regular Python string, that's it. And you can map routes here, that's it. You don't need anything else. You can go and build something like Google, seriously. Of course, that's why we have so many steps here. There will be tools that are good for development, and they will make our lives easier. Time to go, yeah. But again, what we are going to start seeing here are maybe fancier ways to do things, but the concepts are the same. Define a route, return a string, and you are basically done. Something also interesting here is that all the work that we make, this is where Flask is interacting. This is right here where Flask is interacting. All that happens right here from the start of our request processing to the point where we return, it's just Python. If you guys know Python, that's it. You don't need anything else. This is not Flask, right? It's important to understand, for example, when we need to debug something, it's not Flask's fault. It's maybe our code buggy, right? Our Python is buggy, but then it's just a matter of understanding what actor is in charge of what responsibility. All right, so of course there are many more things to see. We're going to see them in a second. Something cool, as I told you that what you guys were returning here was being returned as a HTML content type. I can easily, I'm going to kick off the second example, return a valid HTML code. Well, sorry. See, this is basically, if I check the source code of this page, I see this code, which is basically the same thing that I'm returning here. Even the tabs are preserved, right? Whatever it's being returned right here, it's what Flask is returning back to the client. And as long as if this is valid HTML, it's being interpreted in the right way by the client. Now, of course, if we want to make Google, right, we want to build Google, we will have to, for example, when the user makes a search, we want to create a search page result, right, showing all the resources from our users. So we want to start mixing HTML code with things that we have computed somehow. We maybe went to the database to read it, or we went to somewhere else, right? So we want to start mixing that HTML with data that we have. Again, this is just pure Python. So for example, if I'm not going to use the Google example, I'm going to use the library example. If I want to, for example, show a list of all the authors that we have in our library, I could do something like authors, right? To show all my authors, I could provide a valid HTML list. And here I could do something like authors, right? And finally here, I can pass authors back to the client. Of course, that if these authors should be legal HTML entities, so I should need to do something like authors HTML is going to be something like, I'm going to use list comprehension here. I'm going to do li /li dot format a for a in authors. I'm going to join /n, the join all these things. And now I'm going to add this. And let's see if this works. This might fail. No, it worked. Pretty cool. So as you guys can see, this is, let me check the source code. This is, I have a UL element, right? The one I defined. Let's put a few spaces here so you guys can actually see it. See, we have the two UL elements, and then we have built manually, just pure Python, the text that it's basically containing all the LI elements. All right. So, of course, this is not something we can do, right? This is annoying. We will not, I mean, we can, but it's not really good to build all this HTML by hand. So what we are going to use, there are libraries called template engines that will ease this work for us, all right? We're going to go to the third example. In this case, find it right here. we're going to see the main template engine used for Flask in action. Flask uses by default a template engine called Jinja. All right, it's by default included. Flask is a micro framework, so Flask itself doesn't support templates, right? You have to make use of a template engine library. Well, Jinja is installed by default, but you can easily install a different template engine. You can even use Django template engines. It's up to you. Jinja is pretty cool. We like it. It's fast. It's basically inspired in the Django template engine, so it's familiar. It has a good API, so it's pretty good. We're going to see how it works in a second. Basically, what we guys want to avoid is having to build HTML manually with Python. So we want to transfer all that responsibility to the template engine. Here you guys see an example similar to what we were doing. It's basically you have a way to include a for loop inside your template so you don't have to build it manually. We're going to see more about this later. Don't be afraid. Basically, how it's going to work is you will define a template, right? And a template will consist of structure, sticky, static parts, right? And also dynamic things that should change based on the data that you want to provide, right? So in this case, welcome to library, it's something static. It's also always going to read the same thing, but then we're going to provide different library names when we compile this template, all right? You can think this like a template with holes, and then you will fill those holes with the information you have to construct the final result, right? You will usually have a static template and you will read data from a database, for example, and then you will combine those two with the template engine to return the final response to the user. The way to do that is with this render template string. Again, Flask itself doesn't have a template engine. When we do render template string, it's using by default Jinja. All right. So we are basically saying render template string with this template, this one, and then passing the information, right? In this case, its library name corresponds, maybe these names are confusing. Let me comment this out. Oh, right here. So basically saying there will be a hole in your template with the name library name, and this is the data to fill it out, right? So this one corresponds to this one. It's working. So what is going on here again, it's we're providing the template, we are providing the data, we're combining both with the template, and we are basically making it work. Of course, one issue that we have here is that we are combining in the same function, we're having both business logic, right? This PO library, this information that we're going to use for templates usually will be either computed or it will be read from a database or from an external resource. And we're combining that business logic with presentation logic because this is related to the presentation layer. Usually that's something that we want to avoid. So we want to move this template out of this function. The way to do that is by specifying this as an external file, for example, this one, and I have here the variables to fill, and then instead of passing the string, just the plain string as we're doing here, passing the location of this file. And this is basically what happens in the example number 4. If you guys go to the 4th example, you will see that basically we're saying, instead of render template string, we're saying render template, it's in the different name, and we are providing the name of the template to use. Flask or Jinja, it's basically reading this file and using it in the same way that it was using, well, no, this one, this other string right here. So something important to understand here is that that index.html, it's located in the templates directory, and this is a convention. You can change this, right? But Flask has a convention over configuration philosophy. So usually you just put your templates inside the templates directory, and it should just work fine. All right. I want you guys to stop for 1 second and compare these two examples. In this example, we're providing the template as a string, and in this example, we are providing the template as a file name. You could have built these easily also here without having to rely on Xinxiang. Well, oh, no, it's broken. Here we go. We could have done something like with open templates / index.html, right? Read mode as F, template, it's f.read, right? Read the content and then pass it to the render template string, But of course, Flask is giving us a better way to do it with this render template, because it will also, of course, it will have a way to cache templates. It will have a way to handle errors. Sorry, if the template doesn't exist. I don't know why Flask is working funny on my side. Any questions, guys? Cool. All right, so this is basically what we have seen here. Was, again, we started with this part and we said all we have to do is return a string, and that's basically the required part by Flask. This is just a nice addition. Instead of reading or building the strings manually, we are using a template engine, but basically this is also returning a string. This is a string, and this is a string, and this is all that we need. What we're going to do now is start working with our database. All right. For this simple example, we are using a simple database system that has this schema. Again, super simple. You just have a few tables, right? Book, author, and country. A book has an ID, an author ID, an ID, a title, and an ISBN, and a book was written by an author, and that's how we specified here. We have the author, I don't know, ID 20, Mark Twain, and it's basically when we create a book written by Mark Twain, we should specify the ID 20 here, all right? An author has a name, an ID, and it was born in a particular country, and country just has an ID and a name, and that's basically it. There's also some data if you guys want to fill it up when you start, right? Start to kick off the development. And for this particular example, we're using SQLite 3, as it's super easy to get started. Python has a built-in library to work with SQLite 3, so you don't have to do anything in particular. All right, so simple database up, not this one. What we will be doing here, and I'm going to show you the end result first, we will be reading some authors, the first three authors, these three authors, and we are showing it right here, right? So we have the ID and the name of these authors. This is coming from the database. So what we're doing is as we were doing before, we're just matching a route with a function. And then the Python part is in charge of reading the authors from the database and constructing the end response, the end string that will be used by the response. Of course, we already saw how to return things from templates. We can take a quick peek at how this authors template works. We have a few authors here. And we also saw, again, the Flask part, how to match the route with the function. What we are interested on is in this part in between, which is the Python part that is communicating with the database. All right, so nothing fancy here, nothing even related to Flask. We are just connecting to the database, right? We're creating a database connection with this method, right? ConnectDB is basically connecting to a database, and we are executing a query, executing the select ID and name from the authors. Then we're building a dictionary with authors, and we are passing that dictionary to the template being used right here. So I could, for example, for debugging purposes, oh, by the way, we have a config file, right? This one, that we are importing right here. So it just has the database name, library.db, that you guys can see right here. So what I'm going to do is print debugging info, print what authors contain. Actually, this is a dictionary, so it's going to look better if I use the pretty print module. And let's do print something, so to make it clear. And we're going to reload this page, and you guys can see what's the structure of this data. So it's basically a list of authors structured as dictionaries. If we check this, if we check what the raw data is returning, this cursor raw authors. Did I say actors before? Sorry. We are going to see that, let me move this import to the top, and let me move, let's print first the raw data, pretty print raw authors, and then pretty print the actual authors. And you guys will see, whoa, I broke it. No. The iterator was exhausted. This is actually an iterator. I don't know if you guys know what an iterator is, but if you use it once, you're done. You cannot use it twice. It's exhausted, consumed. So here you guys can see the structure of the data that we received from the database. The raw data are just, it's a list of tuples, and then we're converting this list of tuples to just a list of dictionaries. So then in our template, we can access authors, the first author at the key ID or at the key name, as we have here, ID and name. So it's, I don't know, better, prettier. So we are reading things from the database, and as we saw, this doesn't have much to do with Flask, is more of something related to Python. But in the next example, we will actually make use of some nice Flask features, and one of them will be related to this ConnectDB method. Think for a second that you have several pages in your website, right? You have, or in your web application, you will have, I don't know, read books, create books, delete books. For all of those views, you will have to connect to the database. right? So we are repeating that database connection. There will be a way for us to specify something to do before every request that comes, right? So we will do before every request, before the read that books, create books, delete books, we will connect to the database so we can avoid repeating this connection right here. The way to do that is with a middleware, or it has different names, this hook that basically it's before the before request hook in our app again. So here we're seeing other decorator that you guys can see in action right here. What is going on is that before every request, we will connect to the database. And then once we connect to the database, we're going to store this connection, right? We were connecting to the database here. We're creating a database connection. Then we were using this database connection to execute the query. So we also need the connection in this view. And the way to get that connection is with this she.db object. This is basically the Flask global object. What is going on is that these two functions these are two different functions, so they cannot share data. Maybe this is, we go into much more detail in the advanced course here, but basically due to the scope of functions in Python, you guys cannot just modify global data, so you need to have a better way to share data between the before request function and the hello world function. This is just Python. You cannot easily share data between two functions, right, without modifying the global scope, which is something that is not recommended. So Flask has this she object we are importing here. It has a terrible name, just a she. And this is the global object that we can just do something like she.db, and we can, in the before request function, we can create the connection here and use it right here. All right, that's basically how it works. But if we ever have to create something different, for example, I don't know, books, and we have here books, we can also use the she.db one because it's being connected right here and we can avoid repeating it. Middlewares or these hooks, they can vary to a lot of things, right? So for example, you can check that your views are authenticated. You can check that the views are from a set of known user agents, right? If, I don't know, a robot is crawling your website, you can just like cut it off, you know? So there will be different usages for these hooks. We're just providing one example here that seems reasonable. Something else important here is that in our previous template, we were hard coding the authors. We had 4 authors in our database, and we're just displaying 3. In this 6th example, we're using a different template engine, authors with template engine, and it's basically doing a for loop, looping through all the authors, and we should see it in action right here. Will, remember, you can just unmute your microphone and speak up. Is there an issue, conflict with she if you have lots of routes and requests all going at once? No. HTTP, remember, it's a stateless protocol. So every new request will be considered to be a new request. That's basically how we started. How you run Flask, there will be different ways to run it, and there will be different architectures, and this is maybe too advanced. But basically, you will be able to spin servers that are threaded, right? They use threads. This is a concurrency concept. Or they will be process-based, right? Apache, the regular Apache server is based on processes. Or you can have an event event loop server. So there will be different type of servers, and Flask will have to adapt to that. So if you have a threaded environment, the she object has advanced mechanism to not have conflicts with other threads accessing the same memory. This is really advanced. Basically, it's using thread local Python. You will see some thread local thing here, or local this thing, right? But again, this is really, really advanced. To answer directly to your question, no, she works all right. And that's basically what we use for she, and we don't use just a global variable here, right? We just use the she object. Terrible name, but we use it. You're welcome. So the seventh example, the seventh example, it's basically just the same thing. I am just including authors with conditional. If you guys check the code here, it's pretty much the same one, except we are using a different template. We are just showing how to use a simple conditional. And the eighth example, it's something maybe a little bit more interesting. And we are showing here how to do a join to join these two tables. Let me give you an example. Here, we know that the book and the author table, sorry. Yeah, no, the author and the country, my bad. The author, when we were, for example, let's go back to which one we were running, the sixth one. We are running here, let's also request the country ID. So we also have a country here. Country equals a row at the third position, and authors with template engine from where they from, and we're doing author at country. All right. If I run this, please work. There we go. So when we try to specify in which country the author was born, what we have is the country ID, right? We have a number because that's how our schema was created. So what we want to do is join these two tables, right? This is something related to database, but we showcase it here too because it's meaningful. If you guys want to build something, you will have to deal with this at some point. So what we want to do is basically join these two tables, and that's what you guys can see on the eighth example. I am going to use that one and see what we have from United States, from Scotland, from Argentina. Sorry, there is some background noise in the office. So again, nothing fancy. We're just make use of HTTP, sorry, of Python and SQL. Give me 1 second. Sorry. So we're going to start now with a few more interesting things. The first one is we're going to start dealing with forms, all right? Something pretty common. And here we're going to start working also with the post HTTP method, because up to this point, everything has been just get method, all right? So the first thing I'm going to do is I'm going to show you how this template looks like. In this case, it's basically an empty form. sorry. So we have, if you guys check the ninth example, you will see this simple form here. It's basically what we have here. And it's just a simple HTML form, nothing fancy, but the important part is right here. We see for the first time something new on the route decorator. In the first, we also have the route that we want to match, but we also have a methods keyword argument that specifies what HTTP methods this route will support. By default, I didn't say this before, but all these views will work just for the get method. They will not work for put, post, delete, for anything but the get method. All right? So this is the first new thing that we're seeing. As we will post this form, we're going to post these. See, submit a title. I am posting this information. I want to make this view compatible for both for the get and the post method. This is a simple HTML form. You guys can see the method being used right here. It's a post method. There's nothing fancy to see here. But what also other feature that we're seeing is how we are accessing the request data sent by the client with this request object right here. Once we are inside our view, our function, we can just do something like request.get, to dot method, to check what method the user was using. By default, and this is nothing related to Flask or Python, by default, when you just access a resource with your browser, the web browser is submitting a get method, right? It's just doing get, right? So we can identify that someone is reading from this page because the method being used is get. This form, as I showed you before, will be sent with the post HTTP method. So when I input some data here, this is the title, sorry. These will be sent with a post request. Let's actually take a look at the network. Oh crap. Well, I should preserve the log. And basically when we receive the post request, we can just act on top of that. Of course, usually in these post requests, what we will be doing is, for example, creating, like accessing the database and writing the book to the database, right? We will do something similar to what we did here, but instead of selecting, we will do something like insert into book these fields that were sent here. Also, in this post method, we will usually provide some validation. Does the user have the correct permissions? Is the data valid? Because if I submit this was valid because I'm not doing any data checks. And the data, the ISBN field was empty. So was this data valid, right? So credentials or authentication checks, validation checks, we will do a few things on the post method, and usually it will just end up being creating, a new resource. In this case, a book. Any questions? This form right here is a Bootstrap form. I don't know if you guys know, get Bootstrap. It's basically a front-end, an HTML framework created by the Twitter guys. And these, even though it doesn't look like it, it's just a Bootstrap template. But we are not including the Bootstrap library. The Bootstrap library is just a CSS file. So what we're going to do now, we're going to see how static files work with this example. We are going to We're going to, let's read the template. We're using form with static, and we are including here the bootstrap.css file that it's located inside the static directory right here, and it's basically the bootstrap library. So when I reload these, I will see the same form as before, but style with the bootstrap framework. See, it's pretty much the same thing, but it just has nice styles. So something interesting to see here is basically how easy it is to get started with static files. Right? It's just again, convention over configuration. You put the templates in the templates directory. You put static files in the static directory, and then you just reference it. Right? URL4. You pass the static keyword, and then you just pass the file name that you want to access. Something important to mention here is that when you move this thing to production, you may not want Flask to serve these, because the server in charge of serving the Flask application will usually be a Python server, something like Unicorn or something like that. Usually what we try to do is serve the static files from a different place. The most common setup is using Nginx plus an application server like Unicorn, and Nginx being in charge of serving static files. Why? Because it's super fast, and it's basically a robust server that can take any load, not any load, right? But much more load than a regular Python server. Something interesting here, remember when I told you when we just started that Flask was making our lives easier because it was like taking the complexity out of the HTTP part, and it was, for example, submitting headers by default for us, so we didn't have to take care of that. Well, Flask is doing the same thing for these static files. If we make a request to this bootstrap.css file, and let's also inspect the network here, you guys will see that Flask will make sense of this static file, and will, for example, it will detect that it's a CSS file, and it will return the correct content type here. It's also including some caching information. So Flask is doing a few more things than the one that we can just see, right, at simple site. It's like it's adding a few more goodies. Finally, something else interesting for you guys to see is that once you guys start building, let's see if Bootstrap is a good example, and this is something related to Xinxia. Once you guys start working with your web application, you will see that a lot of this application is shared. So for example, this header right here is the same one for the components page, and also for the CSS page, right? They both look the same. So what is going on here is that there are a few things that are shared among all the pages, and there is some actual data that is changing from one page to the other. The easiest way to do that, and again, this is just to showcase a good feature of Xinxia, is use template inheritance. I'm mentioning this today because it usually has issues with our students. So in this case, this is the template engine this is the template that I'm using, and it's split into two parts. There is a base template, right, that contains the whole base of these, right? It has a title, all these things that are shared. For example, static files are something that are shared among all our views, and then it has a place to provide specific content for each template, right? So this template right here extends from base, and it declares that inside the block content, it's providing the actual content for the page. These blocks, you can create as many as you want, you can put the name that you want, and they have a default value. If you don't provide this block in the child template, the default value will be this one. Questions? No? Good. So something that you guys can start working or doing is trying to getting this simple application that we have right here and extending it in a few places. The first place you guys can work with is, well, when we are reading this information, for example, reading all our authors right here, you can have a few views to read authors, books, or countries. Also, something super interesting to work with is the form. When you guys post to create a new book, again, making a validation of the data and finally inserting the book to the database. If you guys are done with that, I will give you a few projects that we work on during the course. This is the first project that we do on our 4th week. It's basically a Twitter clone. I'm going to send it through the chat window. So you guys can clone it and just work with it by yourself. It basically has tests, everything running, so you guys can start working. It has all the templates, so you don't have to waste time building HTML, and you can just focus on the Python part. So again, maybe working with the form right here, or more reading views, and then moving to the Twitter clone that I have just sent you. You guys good? Any questions? Something? We're going to do a quick introduction to how to build a simple REST API with Flask. So as we had at the introduction example, we also have an API example, super simple. This example works in a similar way. It has a run API, a run app module, and we have a few set of steps to check out. The most important thing to understand here, it's something we cannot do, is how REST APIs work. The key here is to understand that REST APIs work on top of HTTP, and that makes them easy to work with, right? It's like not every, but 95% of the mobile applications that you guys are using will be communicating with the REST API, right? If you ever want to build your own app, you will probably build a REST API in the backend. If you guys want to access Facebook, Reddit, Twitter, you will communicate with a REST API because it works on top of HTTP. In order to work well with a REST API, we have to use HTTP correctly. We have to provide the correct methods for our requests. We have to return the correct status code for our responses and build our data around the notion of resources, right? It's like everything is a resource that I want to either get, post, put, or delete, or patch or something. But basically that's the notion. I'm going to use here curl.it to make a few HTTP requests to the API that I will be building here. So basically, let's spin the server again. Everything is working. This is working. All right. The run app, again, it has a set of steps. We're importing an object app again. And here, this is basically the same thing as we had before. So you guys can see how easy it is to get started with the REST API. We do the same thing. We do provide a route and we match that route with a particular function. I am including a few different ways to like return from this function. The most important thing with this API will be that we don't just return HTML. You guys remember that when we were working with our simple example, we were just returning a string here, and this was returned as an HTML data, as HTML data. For this API, we want to work in this particular example because I chose to. We want to work with JSON. So we have to change the content type that we're submitting. So Flask has two ways to override that default content type and also the default status code, which is 200. And you guys can see both here. One of them is by building a response, right? Building a response. This may be the more, not the most robust, but the most extensible method. Basically, this response will allow you to change a lot of things. Or the other way is by returning instead of just returning, let me open this one more time. Instead of just returning one parameter, adding two more parameters. The second one, it's the status code. The third one are headers that we want to include. So basically returning a tuple. If you guys, I don't know if you guys know, when you return many things from a function, you're basically returning a tuple. So in this case, I will try to access the book resource. So I'm going to do /book. I will tell Orly that I'm not a robot. And I'm going to launch this request. And it basically telling me that the server returned JSON data, basically the content type that I told it to return. You can find it. Where is it? Here, yeah, JSON type, it's application.json, and I have the list of books that I have right here. So if I add a new book, ID 45, author 3, I don't know, to kill and I create the same request again. Corley will require me to check this I'm not a robot thing a few times. I will have now two books, right? So this is a simple REST API. Congratulations, that's it. Again, as we were saying before, everything that follows from here is just Python code. The important Flask part was to understand how to return things that are not default, right? Just like changing the status code or changing the headers that we need. I also have here a way to specify particular parameters that I want to submit. So for example, in this case, I want to get the book with ID something. For example, I want to get the book with ID /45, right? So this 45 that I'm passing here will be matched with this URL pattern, and that's going to be provided here. So these names are not by chance, these names correlate. The name that you guys give to this URL parameter, book ID, will be provided to your function. And then you will be able to basically use your function. So if I get this particular book, you see I'm getting just one book. Questions? There is also a helper called make response. It's in a separate module because sometimes it's the preferred one for some projects. I like maybe this one, but make response pretty good too. So basically what I'm showing you guys here is that you have different ways to return these not default things, right? Like specifying your own content type and specifying, sorry, not just content type, all your headers and also a different status code. Then we can do a post method. We can simulate a post method. So I'm going to kick off the third example. What we are going to do here is we will have a list of books, as we usually do. And we will also have a way to create books. All right? I'm going to showcase it really quickly here. So I have to post to /book. See this one is /book. This is also /book, but this one by default will be method get, and this one is method post. So these two views are not repeated, even though they have the same route, /book and /book. They are acting to different verbs or HTTP methods. So what I have to provide to the book is just a title and an author ID. So I am going to, I'm not a robot, and I am going to add, I'm going to post a body. It's going to be JSON body, and it's going to be, what did I say? Title. To kill an author ID. Yeah, ID. I don't know, 18. And now I am going to post these to my API. Boom. What did I do? I didn't provide the correct content type. Oh man. Add headers, content type. And application.json. Now it works. See the status code that it's returning, 201 created. And this is basically what I am returning here. I am returning an empty body with a 201 created status code. So I have overwritten the default status code, and I have used 201 because it makes more sense to use a 201 when you're acting on a post request. If I check my books, I am doing some nasty global handling here because I am not using a database to keep it simple. But if I check my books here, if I do now a get method, mark again that I'm not a robot. Oh man. Well, I'm not sure about this. There you go. I see that the book that I created before is already there. So Hurley, it's going to give me a bad time. So we're going to check quickly the delete method. It's pretty much the same one as before. We are combining the URL parameter, right? We want to delete one particular book, 34, right? We are specifying which book we want to delete, right? And we are specifying, of course, the correct HTTP method we want to serve, and then everything is pretty much the same. We are just, this is Python, getting the book and returning. We have an abort here with a 404. This abort function, it's a function from Flask that basically, if you provide a book that I don't have in my rudimentary database, I will just return a 404 back, all right? That's basically how it works. This is an just a 404 error handler, but nothing fancy to check out. Finally, what we have is an example using Flask RESTful. Flask RESTful is a pretty cool library to build RESTful APIs. You guys can just use these. Trust me, you can build an API using this. But RESTful is cool because it will add the concept of a resource, right, that you can get, delete, create, right, post in this case, right? And it's basically the same example but built with Flask RESTful, right? So basically you will build a resource and then you will plug that resource to particular URLs. And this is maybe better for a large API. Any question? I see a few here. Yep, Chase and Heather. Yeah, that was it. Ish. So guys, any questions? And then stop sharing the screen. I think we're pretty much done here. How many? Fast 21. We have 60. There's always so many people missing these things. It's so bad because there was people left out. But for those that are not staying. So guys, any question? Again, I didn't hear much questions. I know that of course you're kind of shy because you don't know anyone else. But the idea of this class is, and I'm wrapping up, for you to see how easy it is to get started with these technologies. Python is really cool. Flask is really cool. Once you feel comfortable with Flask, you can easily move to Django. And also to start seeing that you have to start interacting to learn, right? This very same thing that we're doing here, go to your regular meetup and just start talking to people, start building this thing, and let's all build a better community. Of course, we do all these courses, right? It's also a way for us to promote these courses. We do these for an entire month. I guess you can all check out our courses, but it's not just about us. It's start doing this, start interacting with people. We want to change the way we do regular education for coding and for computer science, for coding, for programming, right? It's like everyone is comfortable by having Udemy courses where you just sit and watch someone code something, you know, it was recorded 1,000 years before. We have to change that. We want to provide a better way of teaching and learning how to code all together. Yes, I am going to send the slides one more time. There you go. Those are all the slides, and at the bottom, the last two slides, you can see both GitHub repos containing the introduction, right, the simple HTML project, and the one with the API.
I have a question.
Yep.
Sorry, I think the first one is talking here, but
Good.
Is there a benefit to using an object relational, like what is the benefit of using an object relational mapper like an ORM compared to writing SQL in the business logic?
Well, that depends a lot on the application. If you use Django, the ORM is basically built in, and it's a pretty good solid ORM. ORMs are good until you reach some complexity in your application. If you build a regular application, you just have to create, get data, update data, it's fine. You can use an ORM. It's going to fulfill all your needs. Actually, again, the Django ORM is great. But once you start moving into more advanced use cases, you have to do like complex joins, groups with having clauses, you know, more advanced SQL. The ORM just doesn't work. You will have to write SQL manually. To be honest, I usually find that it's a good mix to use ORM for the simple stuff, and when you need, just write a SQL query. I come from the Java world. Like 10 years ago, Hibernate was the standard. It's like everyone was using Hibernate, and then people start complaining and saying, let's just write manual SQL. I think that it's good to find a middle point, a point in between where you can use the ORM for simple stuff and use SQL for most advanced things. The ORM from Django, it's pretty cool also because it will let you modify your schema and it abstracts you away from the table structure. So for example, when I explain, when I showed the SQL schema, I show you a SQL file today. I show you a table authors, a table book, right? With Django, with this particular ORM, there are others, right? But I'm focusing on this one. You will start with models or with classes. You will say, I have a class book which has an ID, which has a name, and it's related to an author class. And Django will, the ORM will take the data, it will take those models and build the SQL structure or schema that you need to build. And that's something really, really cool, especially when you start working with migrations. If you guys start working with an application, you have your application deployed in production, data changes. You realize that, I don't know, people was able to, I don't know, now it is able to have 2 email addresses instead of 1. So you will have to add 1 more field to your table. How do you change the table? Do you just fire an alter table SQL query right there, or there are better ways. Migrations is one of them. So what I have just told you, it's what I think. It's not the ultimate truth. I don't know.
Yeah, that was great. Yeah.
It's good to mix them both. Do you have any experience with ORMs, SQL Alchemy, or?
Yeah, I've used Django before, which is why I'm asking this. I've been reading a lot about SQL injection, so I'm just curious about from a security standpoint.
Well, that's true. I forgot about that. That's true. Yeah.
So how would that work? Would I just be in that form that you showed? I would put in like a closing, whatever the closing tag, and then enter like SQL job tables or some sort of like raw SQL thing, and that would be interpreted by the business logic of the function on the Flask side?
Well, yes and no, because you can use regular raw SQL and still be protected against SQL injection. You can, for example, let me share my screen again. So we had our post, where is it? Form submission here. We were reading the data, right? These, and we want to do something like, I don't know, db.execute, right? And it's going to be something insert into book values, and here you want to provide these values. So for example, if we do this title and we do format and just pass title, what we got from the request, this is vulnerable. We will be subject of SQL injection attacks. But if you go to the SQLite documentation, you will see that there are ways to pass parameters to your SQL queries that are not subject. Where is it? Here. That are not subject of SQL injection. So instead of manually formatting the string, you will do something like passing a question mark here. And again, just check the documentation for more, but basically you will do something like this. And SQLite will take care of sanitizing the data for you. There are other ways, maybe it is wrong, but basically that's the idea. But yeah, it's a good point. What? Sorry?
I just said thank you. Thank you for showing that.
No, usually it's a good point what you said. Usually ORMs will make it safer too, right? Not just better from a developer standpoint, like easier, but it's also they're also going to make it more secure. It's like the Django RM has, I don't know how many, 6-7 years out there in the wild. They have seen a lot of things, so it's something good. All right, guys. So you're all invited to our course if you ever want to check it out. Again, we have a Slack account which is not really active right now because we had someone maintaining, like in charge of the community, and he's not here again anymore. But if you ever want to drop by, just, you're all invited. And keep it up. Just keep working. Check out the projects we have on GitHub. They're all open, free. Just clone them and start working. They have tests. They have descriptions. They have everything you need. And finally, I forgot to show you something, but we have all the resources that we use for our courses are also free and open, and they are in this platform right here. You guys can check them out too. They have individual assignments and readings, and just go ahead and check it out. So thank you again all for joining. We're always available if you have any question or something. Have a good night. Glad you guys enjoyed it. See you.